In the world of nanotechnology and 3D printing, a groundbreaking innovation is making headlines. Scientists have just achieved the impossible, printing ultra-high resolution 3D microstructures using MXene, a material once thought to be unprintable. First, let's talk about MXene, the dream material that was first discovered in 2011 at Drexel University, USA. MXene is a two-dimensional nanomaterial made of alternating metal and carbon layers. It's known for its exceptional electrical conductivity, high flexibility, and strong electromagnetic shielding abilities, making it ideal for batteries, sensors, and advanced electronics. But despite its potential, scientists struggled for years to print high-resolution 3D structures with MXene. The reason is ink formulation challenges. To print MXene, researchers needed to create a specialized ink, but this presented major challenges. If the ink was too thick, it would clog the nozzle. If it was too thin, it wouldn't print properly. And if they added binders to stabilize the ink, it weakened MXene's conductivity and strength. Existing methods also required post-processing to improve structure integrity, making the process complicated and inefficient. But that's where the game-changing breakthrough comes in. Researchers at Korea Electrotechnology Research Institute, led by Dr. Seol Seung-kwon, have developed a world-first solution called the meniscus method. This technique allows high-resolution 3D printing of MXene without any additives or post-processing. The process begins with MXene nano ink, which is highly hydrophilic and binder-free, making it perfect for printing. As the ink flows through the nozzle, it forms a natural meniscus shape due to surface tension. This meniscus acts like a precision-guided channel, ensuring smooth ink deposition. Then, as the ink reaches the surface, the water evaporates rapidly, allowing van der Waals forces to naturally bind the nanoparticles together, creating an ultra-strong, highly conductive three-dimensional microstructure. The results? A mind-blowing printing resolution of 1.3 micrometers, which is 270 times finer than previous technologies. Compared to its competitors, this technology has some major advantages. First, it does not require additives or binders, meaning MXene's full conductivity is preserved. Second, it enables ultra-high precision, achieving 1.3 micrometer resolution, while other technologies struggle with tens of micrometers. Third, it eliminates the need for post-processing, unlike traditional methods that require additional treatments to strengthen printed structures. This means better batteries, more efficient sensors, and next-gen wearable devices. So what does this breakthrough mean for the future? First, it could revolutionize energy storage by enabling smaller, more powerful batteries with higher energy density and faster ion transfer efficiency. Second, it enhances electromagnetic shielding, benefiting stealth technology, 5G devices, and aerospace applications. Third, it enables next-generation sensors with unmatched precision, perfect for medical devices, AI-driven technology, and smart wearables. And the best part is, Korea Electrotechnology Research Institute is actively commercializing this technology, aiming to lead the nano ink 3D printing market. This is more than just a breakthrough. It's a paradigm shift in 3D printing, nanotechnology, and advanced manufacturing. With 270 times better resolution, a first-of-its-kind meniscus method, and the ability to reshape the future of electronics and energy storage, this innovation is setting the stage for the next generation of high-performance devices. So, what do you think about this game-changing technology? Could this be the future of miniaturized electronics and nano manufacturing? Let us know in the comments below. And if you found this video insightful, don't forget to like, share, and subscribe for more cutting-edge tech discoveries.